Good morning, dear students. How are you? I feel that some of you are worried due to COVID-19 pandemic and the related issues. Is it so? Dear students, please don't worry. Everything will be alright soon. Okay? Yes, good. In the last class, we learned about which topic? Yes, we learned about matter. Then can you tell me what is matter? Yes, anything which occupies space and have mass is called matter. Very good. Also we have learned about particle nature of matter in last class. Don't we? Yes. Today we are going to learn about a new topic. Before going to that, let me ask you a question. Have you ever seen an incense stick? Does incense stick produce any smell or fragrance? Here, I have taken an incense stick with me, and if I am bringing the incense stick close to my nose, I can sense its smell. Now I am going to light the incense stick using a lighter. Here, I have taken the lighter. Now I am going to light it. Now what happens? Yes, the smell of incense stick fills the whole room. So dear students, if an incense stick is not lighted, in order to get its smell, we have to bring it closer to our nose. But if an incense stick is lighted, its smell spreads quickly and fills the entire room. Even a person sitting at the corner of the room will get that smell. What could be the reason for that? Why does the smell spread quickly and fills the entire room when an incense stick is lit? For finding it out, let us first observe a video. Before going to that, let me ask you a question. Have you ever heard about bromine? Bromine is a substance which gets directly converted into gaseous state on heating. In this video, bromine vapor is first collected in a gas jar and then another gas jar is kept on top of it. Dear students, you have to carefully observe the color of bromine vapor, and also you have to find if there is any color change occurring in the two gas jars. Are you ready? Now let us observe the video. In this video, first of all, bromine vapor is collected in a gas jar. Then another gas jar is kept on top of it in inverted position. Then what happens? Carefully observe. Is any color change occurring here? Now let us discuss some questions based on this video. The first question is, what was the color of bromine vapor in the beginning of the experiment? Yes, in the beginning of the experiment, bromine vapor had a reddish brown color. Very good. The next question is, what change occurred in the color of bromine vapor in lower gas jar when another gas jar was kept on top of it? Yes, the color of bromine vapor in the lower gas jar faded when another gas jar was kept on top of it. Very good. The next question is, in the beginning of the experiment, what was the color of upper gas jar? Yes, very good. You are good observers. In the beginning of the experiment, upper gas jar was colorless. Then, what was present inside the upper gas jar in the beginning of the experiment? Yes, in the beginning of the experiment, only air was present inside upper gas jar and it was colorless. Very good. The next question is, in the end of the experiment, what was the color of upper gas jar? Yes, very good. In the end of the experiment, experiment, upper gas star had a light reddish brown color. Then what was present inside upper gas star in the end of the experiment? Upper gas star had a light reddish brown color in the end of the experiment, isn't it? Then can you tell me what was present inside upper gas star towards the end of the experiment? Yes, towards the end of the experiment, both air and bromine vapor are present inside the upper gas star. So dear students, in the beginning of the experiment, only air was present inside upper gas star and it was colorless. But towards the end of the experiment, both air and bromine vapor was present inside the upper gas star and it had a light reddish brown color. What could be the reason for this? Why does the color of upper gas star change? Is here any mixing of particles occurring? Yes, very good. The particles of bromine vapor get mixed with air. That is why the upper gas star, which was colorless in the beginning, changes to a light reddish brown color. Very good. The next question is, bromine vapor and air belong to which state of matter? Yes, bromine vapor and air belongs to gaseous state. Is there freedom of movement or are particles free to move in gaseous state? You have already learned about it in your earlier class, right? Yes. In the gaseous state, particles are free to move or particles are freedom of movement. Very good. So dear students, now we know that bromine vapor and air, they are existing in gaseous state, and in gaseous state the particles have freedom of movement or particles are free to move. And the next question is, for the mixing of bromine vapor with air, do we apply any force or give any energy? Yes, your answer is correct. For the mixing of bromine vapor with air, we did not apply any force or give any energy. Then, how does it happen so? Yes, the particles of bromine vapor mix with air on its own. We do not apply any force or give any energy for it. Or I can say that the particles of bromine vapor mix with particles of air spontaneously. So dear students, now we know that bromine vapor and air are existing in gaseous state. Also in gaseous state, particles have freedom of movement. Also we know that when bromine vapor is exposed to air, the particles of bromine vapor mix with air spontaneously. This spontaneous mixing of different particles having freedom of movement is called diffusion. What is diffusion? Yes, the spontaneous mixing of different particles having freedom of movement is called diffusion. So, which kind of particles will show diffusion? Yes, only particles having freedom of movement show diffusion. Then, for this diffusion to occur, should we apply any force or give any energy? No, diffusion is a spontaneous process. So, dear students, diffusion is the spontaneous mixing of different particles having freedom of movement. Then, can you give me an example for diffusion? Yes, the spontaneous mixing of particles of bromine vapor with air. It is a good example for diffusion. So, now we have learned about diffusion. Then I have a small doubt. Does diffusion has any relationship with temperature? If temperature increase, will the speed at which this diffusion occur increase or decrease? Or will there be no change? Is there any relationship between this temperature and the speed at which this diffusion is occurring or the rate of diffusion? Let us find out it by observing an activity. For doing the activity, I have taken water inside 2 glasses. Inside this glass, hot water is taken and inside this glass cold water is taken. Also, I have taken ink in a small vessel and also here there is a filler. And now using the filler, I will add a drop of ink to hot water and also to cold water. Dear students, what will happen if we add ink to water? Yes, if we add ink to water, ink will diffuse to water. Here you have to carefully observe, is the rate of diffusion same in hot water and also in cold water. Now shall we do the activity? Yes. Here I have taken ink in a filler and now I am going to add a drop of ink to hot water and also to cold water. Carefully observe what happens. Is the rate of diffusion same in both glasses? Yes students, is the rate of diffusion same in both glasses? Here inside this glass hot water was taken and inside this glass cold water was taken. Now let us discuss some questions based on the activity. The first question is, what happens when a drop of ink is added to water? Yes, when a drop of ink is added to water, ink spreads in water due to diffusion. Very good. The next question is, what was present inside the two glasses? Yes, hot water was taken in one glass and cold water was taken in the another glass. Very good. Then, was the rate of diffusion or the speed at which diffusion is occurring same inside both glasses? Yes, your answer is correct. The rate of diffusion was not same in both glasses, or the rate of diffusion was different in both glasses. Then, in which glass diffusion occurred at a faster rate? Does the diffusion occur faster in the glass containing hot water or the glass containing cold water? Yes, diffusion occurred faster in the glass containing hot water. So dear students, is there any relationship between temperature and rate of diffusion? Yes, very good. There is a relationship between temperature and rate of diffusion. Then can you tell me, what is the relationship between temperature and rate of diffusion? Yes, very good. As temperature increases, rate of diffusion also increases. That is why in hot water, diffusion occurs at a faster rate, while in cold water, diffusion occurs at a comparatively slower rate. Very good. The next question is, as temperature increases, will movement of particles increase or decrease? Yes, as temperature increases, movement of particles also increases. The next question is, if movement of particle increases, will the rate of diffusion increase or decrease? These students tell me, what is diffusion? Yes, diffusion is the spontaneous mixing of different particles having freedom of movement. So, when movement of particles increase, will the rate of diffusion increase or decrease? Yes, as movement of particle increases, this mixing of particles, they will occur at a higher speed, and so the rate of diffusion also increases. Very good. So dear students, now we know that as temperature increases, movement of particles also increases. And also we know that as movement of particle increases, the rate of diffusion also increases. Then can you tell me, why does the rate of diffusion increase with increasing temperature? Yes. As temperature increases, movement of particles also increases. That is why the rate of diffusion increases with the increasing temperature. So dear students, as temperature increases, rate of diffusion also increases. The reason behind that is, as temperature increases, movement of particles also increases. So particles can more fastly mix with each other, and thus rate of diffusion will also increase. So in this class, we were learning about diffusion. What is diffusion? Yes, the spontaneous mixing of different particles having freedom of movement is called diffusion. Also, we learned the relationship between temperature and diffusion. Now I will ask you a question. Based on what we have learned till now, you have to give me the answer. The question is, why does the smell of an incense stick spread quickly in a room when it is lit? Yes, when an incense stick is lit, its temperature increases and the particles present in incense stick get converted to gaseous state. In gaseous state, freedom of movement of particles is very high. So the particles diffuse quickly into air and spread throughout the room. That is why the smell of incense stick fills the whole room when it is lit. Now I will give you some homework questions. You have to write its answer in your science diary. Now all of you note down the question. The first question is, what is diffusion? What is diffusion? The second question is, what is the relationship between temperature and rate of diffusion? What is the relationship between temperature and rate of diffusion? This question, it is an activity. You have to do the activity in your home and you have to record your findings in your science diary. The question is, add a drop of food color to oil and water. Carefully observe what happens. Record your findings in your science diary. I will repeat it once more. Add a drop of food color to oil and water. Observe what happens. Record your findings in your science diary. So dear students, today we were discussing about diffusion and the relationship between temperature and rate of diffusion. Do you have any doubt about it? Is it clear? I hope you have understood it well. So thank you and have a nice day.